Here's what we know so far about similar triangles. The corresponding side lengths of similar triangles are proportional. This means the ratios of the corresponding sides are equal. So what if we have a triangle within a triangle as pictured in number 1? Sometimes it's difficult to know which side corresponds with which side. So I suggest that you draw and label as 2 separate triangles to better visualize the corresponding sides. We have the side DB that corresponds with the side VB because they were shared in the original diagram. We have the side CD that corresponds to side UV because they appear to be parallel. And we have the side CB that corresponds with UB because they share this side. Now that we know the corresponding sides, we can set up a proportion to solve for x. I like to always start with the big triangle, big over small. So I'm going to put the side with x in it, which we need to find, over its corresponding side in the smaller triangle, big over small. This is my first ratio of side lengths. The next one you can choose. Do you want to use the blue side over its corresponding side length, or do you want to use the green side over its corresponding side length? Either one will work. I'm going to use the blue side, 50 over 10. Now that we've set up a proportion, we can cross multiply to solve. But anytime you have a group, such as 6x plus 9, you must put parentheses around it to remind yourself that when you cross multiply, you will also need to distribute. All right, let's look at our first multiplication. Numerator times denominator. So 10 times 6x plus 9 is equal to the denominator times the numerator, 9 times 50. Now it's time to distribute this 10. 10 times 6x is 60x. 10 times positive 9 is positive 90. And 9 times 50 is 45 with a 0. To continue solving, I'll subtract 90 from both sides and get 60x is equal to 360. Divide both sides by 60 and x is equal to 60. Now let's take a look at example 2. For this one, you'll need to actually label the side lengths. They have not been given to you. Go ahead and fill in the side lengths on the 2 separate triangles from the diagram given. Okay, so we have the side PR, which is 21. So the side PR is 21 in measure. Then you have the smaller side that corresponds to PR, which is FR, and that measures 2x minus 14. And then we have the side RQ, which in total measures 39. And its corresponding side on the smaller triangle is RE, which is represented by the length of 26. And the last sides that correspond are the sides that appear to be parallel. So PQ on the larger triangle, which measures 42, is the corresponding side to FE on the smaller triangle, which measures 28. Now we have the corresponding sides. We have a visual to see which sides are corresponding, and we can set up a proportion. Again, I like to start with the big triangle, big over small, so that if I do it the same way every time, I don't confuse myself. But it's up to you. We definitely have to use the yellow side because that's the one with the X in it. So starting with the big triangle, 21 corresponds to the side 2x minus 14. So our first ratio will be 21 over 2x minus 14. That will be equal to, and now you can decide, do you want to use the blue side over the blue or the green over the smaller green? Either ratio will give you the correct answer. I'm going to use the green values this time. So big green value is 39 from the big triangle over the green value from the smaller triangle, the corresponding side length, which is 26. All right, before I cross multiply, I see a group, 2x minus 14. So I need to put parentheses around that to remind myself that I will need to distribute when I cross multiply. Go ahead and solve this proportion for x, and then click Continue to check your work. And the correct answer is x equals 14. Try to label the two separate triangles at right from the given diagram. Now this one's just slightly more challenging. It should be noted that since x occurs basically between these two lines, x is only the length between these two lines. Because 10 is labeled in the middle of these two lines, or these two vertices, this is the side length that measures 10. So what does this entire side length measure altogether? That would be this portion plus this portion. So x plus 10 is the length of this long side on the large triangle. Now the side x plus 10 corresponds to the side in the same orientation of these triangles, and that would be the side right here between these vertices. So the side on the smaller triangle, that is 10. So the corresponding side on the smaller triangle to x plus 10 is just 10. Now let's take a look at our other corresponding sides. We have 18 on the larger triangle, which is this left side, and we have 3 on the smaller triangle. And they didn't actually give us another set of sides, so we will just use these two ratios. So I'm going to start with x plus 10 over 10 as our first ratio. And then we have the other side, 18 over its corresponding side, 3. Now before I cross multiply, I see a group, so I need to put parentheses. All right, now it's time to cross multiply and solve for x. When you're done, click Continue to check your answer. And our final answer is x equals 50. To review, the way that we can solve these is because we know that they're similar triangles. They must be similar triangles. And if they are similar triangles, then the corresponding side lengths of the similar triangles are proportional, which means the ratio of the corresponding sides are equal.